All right, welcome everyone to this talk about Beyond Lambdas, the aftermath. My name is Daniel Deogun. This is my colleague, Daniel Sawano. Let's show a really boring slide. We're both from Omega Point, a consultancy firm in Stockholm. It's actually here in Gothenburg as well. But please Google this in case you're interested.
So let's move to something interesting then.
Yeah, let's jump into the code. But before we really do that, let me ask, how many of you are actively working with Java 8 today? Good, there's a bunch of you. How many of you are about to move to Java 8? So we know that as well. Okay, I hope every one of you finds something that is of interest in this talk and that can bring with you to your current project. And let's jump into the first example. It's a very trivial one, I think. So Daniel, what do you see here?
It's some kind of basic if-else statement. I guess there's an advice going on here. So I guess if we do have an advice, we can get a cheap advice, right?
Right.
Otherwise, we'll need to go to the almighty Oracle, right?
You all know going to the Oracle is expensive. But this is classical pre-Java 8, Java 6, 7 stylish type of code. But now when we're moving over to Java 8, of course, we figured that, oops, something happened to my mic. You guys can hear me. We figured that we're going to use something called optionals, because optionals is going to be an abstraction of null. So Daniel, how would we rewrite this in Java 8?
Okay, let's take a look. How this can look in Java 8. So I guess we've written the same logic here. I go with create an optional, and if we have one, a value in that optional, we will map it. And then I figure, there's an else branch there, so I just use or else, Oracle, get expensive advice. Looks pretty straightforward, right?
Looks straightforward, but it turns out that this is actually wrong. This is a very common mistake made by novice Java 8 programmers. It happens to be the fact that they have mapped the else branch of an if statement that we just saw to the else clause in the API of a data structure called optional. And that API is eager. That means that API is always going to get invoked. So this particular code is actually going to give you both a cheap and an expensive advice, which is really not what we intended.
We prefer the cheap one, right?
We prefer the cheap one, right? So, Daniel, how would you rewrite this?
Well, let's look what our other options we have. We have an or else get that takes the supplier. So let's rewrite this and use the supplier, and we will...
You actually forgot to get.
Yeah, could use that one too. In the form of lambda. And now suddenly we have a lambda that is only executed or evaluated once we need it. So now we actually only pay for the cheap advice if we have one.
I did talk to Brian Getz about this, because as you saw there, many people tend to do that unintentional mapping. And he said this was actually the convention used in Guava. That's why they figured they would use this in Java. And well, it's not, I would say it's not optimal that we actually have an eager else API that people tend to use. So please use or else get. And that was what you're going to do. Okay, moving on.
Move on. Get that to fit. All right, some more optionals here. Here we have a method called underscore, but of course you would call it something more meaningful in your own code. And it takes one argument of the type optional, right? And what do we do here? We let's see. We'll map it. If we have one value, we will map it by calculating a new value, and then we will filter it through some sort of criteria. And if that criteria applies, then we will map it again, and we will transform the value. And at the end, if we didn't get any result out of that, we'll perform something completely different. Pretty straightforward, right, Daniel?
Yeah. I mean, this really made me feel good, right? It's a one-liner, map, filter, map, or else. It makes you feel powerful, right?
So your entire program in one line.
Programmer doing the functional stuff.
But there actually is something fishy going on here.
Right.
So in order to help us spot that, let's rewrite this and write it in non-Java 8 style.
Okay,
see how that would look like.
Let's go to something like Java 6, Java 7 style.
Okay.
And see what
now it becomes a lot more clear what is going on here. And basically, if we have a value, we will perform some sort of processing. If we do not have a value, we do something completely different. So what we're doing in this method, and I hope most of you can see this, we're actually doing two different things. So basically, we are violating the single responsibility principle that we all know and love. So most of us wouldn't write code like this before we got Java 8, but then we turned into Java 8 and we forgot all this, the best design practices when we start using optionals and so on. So let's try to rewrite this, still using Java 8, but not violating the single responsibility principle. So how would that look like, Daniel?
All right, so let's bring that up. I guess you need to do that forking outside of the method, right?
So now we only want one method to do one thing. So we extracted the first part into a method and call it first calculation, where we take an actual value, not an optional anymore, we calculate, we filter, and we transform, right? So that's the first part, and then we perform a flat map on the result from that, and then we do the or else get and perform the completely different calculation. So now our methods only do one thing, and the forking, as Daniel said, takes or occurs outside of the methods.
So Daniel, that really makes sense. I get the part with the forking. But now in Java 8, since we are having optionals, and I'm getting that result back, it's probably going to be cases where I want to take that optional and pass it on to some API, right?
Okay.
Some public API.
Okay. So we just look at an example. The takeaway from this example, I guess, is if you're passing in an optional as an argument, be aware that it might be a sign that you're actually doing more than you should do. Mm-hmm. So the other thing that Daniel just mentioned, let's take a look at that. Another example of passing an optional in as an argument. Here we're doing something very simple. If there is a value, we do something with it. Pretty straightforward. Mm-hmm. But again, is this really what we want? Let's rewrite it into non-Java 8 style. All right. To make it more
let's do that.
Accessible for those of you who are not fluent in Java 8 yet.
Old style, I guess that would be T then, right?
Yes, an argument of type T, and then I guess we would check if it's null.
So if argument not equals to null.
And if it's not null, then we want to do something with it.
Okay.
So if you look at this piece of code and ask yourself, would you write code like this? Because what you're doing here is you suddenly said that, okay, I'm going to accept bad input. I'm going to accept null, which is, as far as I'm concerned, bad input. And then we have defensive coding all of a sudden, a defensive code construct saying that I'm going to check if it's not null, and then I'm going to do something. So what's the problem with having all these defensive code constructs?
Well, I guess the main problem is going to be that you're going to get bad data, or let's say illegal input, zippering through your entire code base without you noticing. Because this actually has an else branch that you don't see, and it doesn't do anything, and it just passes on, and all suddenly someone is not being this defensive, and it blows up. And of course, you're going to start investigating why that blew up at that particular point.
Exactly. Or you never blow up, you just pass that bad data through your entire system, and you end up with some weird result, and you're probably going to end up with a weird result in production because you didn't have a test to caught that. And it's going to be really hard to find where it actually went wrong, because you're being resilient everywhere and mapping, and or in this case, if you make it more clear, having defensive code constructs. So instead, you should just, when you find an invalid data, then you should handle it immediately, not just silently try to avoid it.
So you're saying that we should actually have made it like a guard here, right?
Exactly. That would be a very crude way of saying I'm not going to accept bad input.
Like that, something.
But
like that,
basically remove saying that I'm not going to accept bad input. So if you have bad input, then don't call me in the beginning, in the first place. So again, an optional as an input parameter, especially to a public method, if you write that kind of code, or if you see that kind of code, stop and think again and say, okay, is this really what my intention is? Because it can be a sign of some fishy things going on in your code base.
So don't do the branching, and also don't pass it in as an argument to public method.
Exactly.
Okay, makes sense. Okay, moving on.
Next example. Okay, so we're leaving optional and moving into streams, right?
Right, we all know streams. I mean, that's one of the big things of the new Java language. And I don't know, what's wrong with this? Please run it.
Is there anything wrong?
Yeah.
Sorting and joining and collecting.
See what's going on. Whoa, that null pointer exception. We all know it. We don't like it. And what's really interesting is actually the stack traces when it comes to Java 8.
Oh, there you can see it.
They haven't really changed in any way, but I guess the normal method of working in Java 6 and 7 is, of course, to click on the blue stuff in your IDE.
Click, click.
So we click on that, and what's going on there?
Okay, we got collect and joining.
Uh-huh.
Something's wrong with collect or joining.
So there's a null pointer going on there, right?
Yeah.
No. In Java 8 and streams, we introduced something called intermediate and terminal operations. And this is something that's new. The intermediate operations only get executed whenever needed. And those are usually just executed when the terminal operation occurs. So, in this case, it turns out that the bug is really in an intermediate operation. And a novice Java 8 programmer might actually start looking at the wrong place because of that. They don't realize that. So, Daniel, can you just move up in the stack and see what actually really went on?
Let's see, we got, here we got some hints. This is a comparator. Let's jump into that one, see what that says. Okay, I guess it's obvious. If C1 is null, we're going to get a null pointer. So it becomes pretty obvious. So
it was actually in the sorting operation, and that occurred a lot earlier. And of course, I mean, this is a very trivial example. In a much more complicated one, we have flat maps, skip, and all sorts of things going on there. You might actually miss what actually is going on. But a more senior developer, I guess Java 8 type of developer would actually start looking inside of the intermediate operations. So that's the key takeaway here. Remember those.
Okay, so how can we solve this? And I guess, you know, senior not as being old, but being fluent in Java 8. So let's see, how can we solve this? I guess one way would be to get rid of all the null values. Because
right. I mean,
the basic idea of having a stream,
nulls, right?
Exactly, a stream with null values is a little bit weird. So let's filter those out. I'm sorry.
I mean, if you can't fix the data, you of course have to be resilient to it. So,
see if I can spell.
There you go.
That should.
And just run it to make sure that it actually did. Fixed it. Yeah. Well, good.
It's green.
Moving on. Okay, so what do we have here?
Okay, so a little bit of more streams. In this example, we have a imaginary service that has one method. It's called items matching, and you can pass in any predicate you want. So I guess that service will return all the items that will match the given predicate. And here we create a predicate that is checking the ID of the item. So I guess it's an ID filter. We filter out all the items with a given ID. And in this case, I, as a developer, knows that the ID of an item is unique. It's kind of like the primary key of the item. So I know that if I will get something back from this method, I'm probably going to get an empty stream or a stream with just one item. Okay, so if I get one item, I can just use, you know, find first or find any. That's the easiest way to get the actual element in the stream, or one element. And then if I get one element or item, then I will do something with it. Okay, it's pretty straightforward.
Mm-hmm. So what's the problem with this? I mean, it seems to work fine. Let me run it and see if something's going on.
Yeah.
Something fishy.
Okay, so we get an item. Perfect. Now the issue here is find first and find any. You know, I based this code on my assumption that the ID is unique, but what if the API of the server doesn't make any guarantees about that invariant? Right, there's nothing documented there, or there may be a bug. What if I get more than one item back? If I use find any, I'm just going to get any one of them. Find first, I'm just going to get the first one that happens to be returned first by the service. So that would make my code non-deterministic. I don't know what I'm going to get anymore, right?
Well, I guess the API actually has an S in there. It says items matching. So there could be multiple matching.
Exactly. So the assumption that I made is kind of like an implicit invariant that I know about, but the API doesn't document. So let's run it again and see if it actually has a bug.
Oh,
Okay, it's an item with the ID 6, but it's a different item. It has a 4 at the end, and 6, and so on. So we have a non-deterministic behavior in our code. So a way to solve this is, instead of using find first or find any, there's a really nice method on streams called reduce. And if Daniel will refactor this code, the reduce operation takes a binary operator as an argument. So if we pass in a binary operator that only does one thing, it blows up. So now we've introduced an invariant checking that we're actually getting valid results back from the service.
okay.
So now we should be protected, or we should find these types of bugs when we actually get more than one item back. Let's run it and see if it works.
Let's run that. Oh, wow.
Yes. So now we protected us by enforcing this invariant. We get a contract on that. And of course, this kind of messes up the nice readability that we had in our stream statements. So I guess we can refactor it a little bit.
I'll just do some Uncle Bobbing.
Yeah, let's Uncle Bob the code.
So let's Uncle Bob to only one. I guess that's a bug in IntelliJ here. Yeah, there we go.
Or we can spell right too, to make it even more readable.
Let's make it even more readable.
I don't think.
There we go.
I don't think Bob mentioned spelling, so it doesn't matter.
There we go. Sorry about that.
Yeah, that's a lot nicer. Okay, so now we're using reduce instead. So I guess the takeaway here is, when you write find first or find any in this kind of constructs where you only want one element from the stream, think again, and a lot of times it's because you're making some kind of assumption, and you think that the easiest way to get just that single element is by using find any. But you might actually introduce possible bugs. And it's very common to see when you're starting to convert pre-Java 8 code into Java 8. That's when you start seeing these kind of type of constructs. So let's move on.
Moving on.
What do we have here? More streams.
Yes.
So in this example, we have a user service and an order service. A user service simply gives your application the current logged in user. Very common to have in applications. And we have an order service that can manage orders. And let's say this is probably some kind of web shop or something. So we can get all the items that the currently logged in user wants to buy. So we can get those items, and then we can create a stream from those items, and we can map each item into one order. And our order is simply contains the ID of the item that we want to buy and the ID of the current user. And then we will send all the orders away to the order management system. Pretty straightforward again. So, well, let's just run it and see if it works.
All right. Let me run that. So we sent 30 orders. That's pretty good.
Works perfectly.
But it was kind of slow.
Yeah, so we kind of progress, and our applications are slow, and we think that, well, you know, how can we make this faster?
I know a way. Since I've been reading about Java 8, one of the first things I actually encounter is parallel streams.
Yes, the parallel stream. Everyone who makes a talk about Java 8 will talk about parallel streams. You can just define your stream, and then you can turn it into parallel execution.
By magic, one-liner, I can make it fast.
Exactly.
Right.
Now, of course, a disclaimer, this is a pretty academic example. In the real world, whether or not your application will be more performant, whatever performant means to you, by using parallel streams is a totally different discussion. But in our case, we've decided that, you know, we really do believe parallel streams will benefit us. So let's try it.
So I just added it.
Oh, major refactoring.
Yes.
Parallel streams. Let's run it.
Oh, you want to run it? Okay.
It should work.
Whoa, what happened here?
What's happened?
Oh, I guess you can't see this. There we go. No current user found.
Current user.
I think you have a bug.
I don't write bugs. I stopped doing that a long time ago. Let's jump into the current user method and see what it does.
Current user, I guess it's over here.
Okay, so it has a current user. Oh, it's a thread local variable. That's also very common to see in all kinds of libraries and framework. What does that mean? Well, it means that that field is bound to a specific thread. And what did we just do when we turned our stream into a parallel stream? We made it parallel, which means all the operations on the stream will be executed on a different thread or any thread that happens to be available in the underlying fork join pool. And of course, that thread is not going to have the current user. If this wasn't a web application, the current user would be in whatever, maybe the request thread in the HTTP.
So doesn't that mean we need to apply the same principles as we do with any concurrency? I mean, we need to provide this dependency explicitly.
Darn.
Ah.
I just hope parallel stream could make us forget all about concurrency in multi-threaded code. But apparently it doesn't. So how can we solve this?
I'm just going to extract this into a variable, of course.
Okay, that's smart.
Provide that to the expression.
Okay, so Daniel just moved it out. So now the user, we extracted that from the current thread context. Now it's in a local variable, and then we're passing that into our stream. So now we should be able to process all this in different threads. It works again.
Right, and it's of course super fast now.
So I guess what you just said, parallel stream is an extraordinary tool that can be used, but we still need to go through all this, I wouldn't call it pain, but we need to be aware of how to write concurrent code and multi-threaded code.
So be careful. Use parallel streams whenever it's appropriate, not because it's cool.
And obviously, this is a very easy example, and you think, that's obvious. We can see it through a local. But in the real world, this is probably going to be buried under, millions or a lot of code somewhere deep down in your library. And if you don't know your library that good, you may run into these types of problems.
Okay, so let's move into the next realm, functions.
Okay, functions. That's another cool thing, and all that comes with it. In this example, we have a method called number of free apples, which takes a user, and then it takes a function that can calculate a food ratio, and then it, I guess, multiplies that with 2, and in this case, it will determine how many free apples you will get after lunch on this conference. So I guess if you're older, if you're 13 or older, you will get
4 apples, right?
Yeah. Otherwise, you'll just get 1, because if you're a kid, you don't need to eat so many apples. So yeah, let's run it.
All right, let's run that.
See what's
going on. Oops, sorry about that. There we go.
Okay, so this particular user, some user there, he or she will get 2 apples.
There's young people here.
So is there? Why do we have this example? Is there something wrong with it?
I mean, it looks fine to me. I mean, I'm using function.
Well, I think there's room for improvement here.
Room for improvement.
So if you look at the method signature or number of free apples, we're using a generic type function, so it doesn't exactly communicate its intent very well. I mean, okay, we got a pretty good name on the method, and we named the arguments on the method, which is good, but still you can pass in any function that takes a user as an argument and returns an integer.
But come on, the name is food ratio.
I know, but
right,
we make mistakes when we get code. So let's show a possible mistake that you can do. There's nothing preventing you from passing in a totally different function. So in this case, we have a function that is calculating or providing the age of a user. So we can pass that into the number of free apples. And I think we're going to get a lot more free apples if we do that.
Really? Okay, let me see.
Depending on how old you are, I guess.
Oh, wow, 24. That's a lot of apples.
You can take it home, you can eat it for a week.
Yeah.
So one way to kind of improve this would be to start using domain-specific types instead of generic types. So if we try to refactor the number of free apples method, and instead of using just a function, we can define our own functional interface.
Okay.
That we can, I guess, call food ratio strategy. And we can annotate it with functional interface, and then we will get some help from the compiler, in case we violate that contract. So now the method signature of our method has become a lot more clear about what we want. And we're also going to start get some level of help from the compiler.
So I guess if I would just comment this line in, and as you can see here, you get a red marking by the ID.
It's of the wrong type, right? And obviously, I said some level of help. I mean, you can still kind of cheat. If you start inlining that, you would be able to pass in that age function again. But so you're not completely protected, but at least you improved the readability and the intention of the method number of free apples.
Like this, you mean, right?
Exactly. Then you would still be able to make that mistake.
Right.
And of course, the reader who's been thinking a lot about this will notice that, okay, well, if you define your food ratio strategy like this, then you can't use it and do cool stuff like map, flat map, and all that stuff because it's not a function. And in this example, it wouldn't make sense to let it be a function. But I guess if you want to, you could extend function and have your domain-specific interface. But then again, it's turned into a function, so you can start passing in all kind of stuff. But that would be one option.
So I guess the key takeaway here is that by using the generic functional type, you open the door for a lot of functions.
Exactly, and you're losing a lot of the explicit intent of your code, which is, we shouldn't forget that just because we got all these new tools. Like we don't use strings as our domain objects. We want to use something specific.
So let's move on to a little bit more complicated functional example.
A very appropriate example, because we're in Gothenburg.
Since we're in Gothenburg, we're going to build cars. And of course, Daniel and I don't know anything about cars, but we're building a Volvo.
I know how to drive one.
Yeah, and a Tesla. And apparently, a Volvo only had 250 horsepower, whereas the Tesla has 1,000. Please see if that's true.
1,000?
Yes, it's green. It's true. All right. So what's the problem with this? Well, as it turns out, the engineers, they realized that the difference between building a Volvo and a Tesla is really the engine. So when they were developing this, they had their factories for building their particular cars, but they said, hey, I want to minimize code duplication. So I want to pass in that specific behavior of an engine to a generic factory. Okay, and in order to pass that behavior, we're using the function API.
Oh, yeah, I see what you're doing here. You're thinking dry.
Yeah.
Reusing the generic factory. Cool.
So please show me the code, I guess. Go into the Volvo factory, that's fine. Okay, as we see here on line 21, we are using the generic car factory, and we pass in a function to the engine method that you have underneath there. Maybe Daniel, there we go. Which is fine. And the same thing goes on in the Tesla factory. You pass in a function to the engine factory, which is fine. And that gets applied. All suddenly, business comes along. And business just told us that, you know what, we have this new requirement. Every engine needs a generator. Now you're nodding your heads. That's good. So Daniel, please add a generator to that engine.
Okay. So how do I get a generator? Let's poke around a little bit. So, okay, it turns out that the car factory can give me a generator. Cool. That's one step on the way. And then, well, you want the engine to use that?
Oh, yeah, please.
Okay, so I'll pass it in, and then I guess we'll solve this later.
Oh, yeah. Do stuff.
Stuff.
So you push this into your delivery pipeline, and what happens?
I guess our tests will run.
Yeah,
so
I guess that's the point. We need to push this out to our customers.
Oh, Stack Overflow error. I hope that's not because I copied the code from Stack Overflow.
Oh, yeah, that's a web page, I guess.
Oh, that's a different Stack Overflow.
This is weird. You only invoked the generator method. But apparently, we seem to have an infinite loop. Somehow, there's a circular dependency going on. So let's jump into that generic factory, please. Let's see if we can see anything. There we go. Apparently, I mean...
Can everyone see that, or is it too small? Should I zoom in more?
I think we're good.
Yeah.
Apparently, we seem to have a dependency to horsepower. But in order to get that horsepower, of course, they use that engine strategy that we passed in while we were building our car, right? And we applied it, and therefore we got an infinite loop. And the key takeaway here isn't really this poor design of why didn't we have an explicit dependency to horsepower instead of that engine strategy. The problem is that first of all, we have broken an encapsulation principle. The engine method is private. And imagine this going across modules, multiple classes, and so on. It's really hard to understand how this is used. The second thing is that neither the compiler or the IDE warn us about the circular dependency. And that makes it really hard for us when it comes to refactoring and redesigning this piece of code and reusing it. And that's the key takeaway here. If you use functions, and if you use it in this way, that you pass in behavior this way, it can get nasty really quick. So be careful. We like functions, but be careful. Moving on.
Moving on.
Right, so what do we have here, Daniel?
Okay, we have a list with a couple of numbers. We have another method that can get us, I guess, the even numbers, right?
Mm-hmm.
And then we got a hello world.
So this is actually pretty straightforward code. But as it turns out, a lot of developers tend not to understand, how funny it might seem, that Java is an applicative language, which means that whenever a statement is applied, it's going to get used. Whereas in other languages, such as Haskell, it uses normal ordering. And normal ordering is really about using or evaluating a value whenever it's needed. So in this piece of code, we will actually evaluate is even, which is you see there down in the filler operation, even though we don't use the result from it.
Which I guess is perfectly normal for us Java developer. We're used to that.
Yeah. So let's run it and see what it looks like. Yeah. Not surprising. Yeah. So you say hello at the end, and we also do that. But as it turns out, with Java 8, we now have a chance to start simulating normal ordering. And how would you do that?
Okay, so that would be abnormal in Java.
That would be abnormal in Java, but you know, okay. This is really.
I guess one way is to use the supplier interface, right? Mm-hmm. Which can supply something to us.
Supplier is always giving, right? It gives us, supplies us with stuff.
We can define that in terms of a lambda expression, right? So and the lambda is kind of lazy. It's not evaluated until you need it.
Right.
So now we've got the abnormal order. I'm sorry, the normal order.
Right. So let's run that.
Let's run it. Then we just get hello. Okay.
Yeah. And then you might say, okay, well, what's the point of all of this? Well, when you start refactoring your old code, then you can start using these kind of tricks in order to say, you know what? We don't need to do this pre-computation anymore. We can actually place this inside of suppliers or whatever structure you want and have it lazily evaluated. And then it's going to be used at a later stage. So how would you have done it to extract those numbers, or are they gone now? Or what happened?
No, I can still get them.
You can still get
just call the get method.
Oh, okay.
Then I get them.
Uh-huh.
So then it will be executed again, just like before. So they're still there, but they're not going to execute until I actually need them.
So that's a neat trick for you to use every now and then. Okay. So now we warmed up. We're going to move into a much, much heavier Lambda example.
This is just streams again, right?
Yeah, it looks like it's a stream.
Yeah.
Mm-hmm. But as it turns out, a lot of experienced Java developers, Java 8 developers, tend not to understand the difference between a capturing and a non-capturing Lambda, or a stateful versus stateless Lambda. So, Daniel, this is actually a capturing Lambda. How can we tell?
Well, yeah, well, the giveaway is we're using something that is from the surrounding context, right? Mm-hmm. That's the giveaway in the code.
Right.
That tells me it's a capturing.
I actually have a dependency to this here.
Exactly.
So
the other thing, okay, so you talked about having a static Lambda.
Right.
I'm sorry, stateful or stateless.
Mm-hmm.
So how do I write a stateless Lambda? do I do like, is there a keyword, or can I do
No.
stuff like this, or?
I think first of
can I
all,
say
we need to go down deep. I think we need to go down in the basement to really look at this.
Ah, you mean down to the bytecode level?
Oh yeah, of course.
Finally some bytecode. So I guess we'll compile it. I love compiling. And then I guess I have to decompile it. Right.
So we're going to use the Java P tool. Of course, you all of you are using the Java P tool every day to view your bytecode, to understand how it looks underneath. See if we can get this to fit.
Does it fit? No, still.
Almost.
Almost. But
that's good.
I think
this is the important part down here, though. Yeah.
Because here's our lambda. That's how it turned out in bytecode. And I guess this is where we actually invoke it by invoke dynamic.
Right. So as we can see here, that lambda down there is placed inside of an instance method. That means that lambda cannot be evaluated without having a dependency to this. And that is actually fine, because performance-wise, the worst type of performance you can get from that is really from using inner classes. But if you want to unleash the full power of lambdas, you want to make that stateless. And you also want to make it static. So how would we do that?
Okay, so I guess the removing the dependency to this, one way of doing that would be, I guess, something like this. And then now the lambda is using a local variable instead.
Right.
That should fix it, right?
But the method is, of course, referencing this still, but the lambda isn't.
Yeah. So we changed the lambda. That's our hypothesis. So let's check the code. How did this turn out in bytecode?
Oh wow!
It's changed a bit.
Changed a little bit.
Now we have a static declaration of the lambda.
And also, if you inspect the actual instructions in there, you can see that there's no need for referencing the surrounding lexical scope. This, which is pretty nice. But moving back to that code again, I mean, I really don't want to place my fields inside of temporary variables, because that's probably going to get refactored away. Somebody is going to go, hey, what is this Daniel doing? He's placing all those fields.
Unnecessary local variable. We just remove it, and then it's all gone.
And we'll back again.
So I guess another way would again be making it focusing on readability rather than trying to optimize on a very low level. So let's extract this to a method. I guess we can call it matches, and then again we do not want to reference to this, so we'll take it as an argument. Okay, and let's get rid of this. Just clutter. Okay, so now we focused on readability, and so this is the same thing.
Let's run that in.
I guess we can even make it static just for sake. So let's see how this bytecode turns out. Okay, so it's still a stateless lambda.
Yeah, which is pretty nice.
And it's still non-capturing because we're not referencing the surrounding scope in our lambda.
So I guess the key takeaway here is that, of course, you should not think about bytecode performance in this way when you write your everyday code. But you should focus on readability. And believe it or not, a lot of newcomers, they feel that, E arrow E is actually pretty complicated. They need to spend at least a second thinking about it. So that's a little harder to grasp, at first at least. But filter matches pattern is actually pretty easy to understand.
It reads almost like a sentence.
Yeah.
And of course, we're not saying that you should convert every single lambda in your code to a method, because that would just create too many methods. But in real life, a lot of times your lambda is going to be pretty nasty. They tend to be that. So actually extracting it to a different method makes it a lot readable. And as Daniel said, suddenly just by focusing on readability, you will actually get better performance under the hood. And you shouldn't think about bytecode, but you should be aware of these, what's actually happening, what happens with your lambda.
Right. Okay, I think we have about 4 minutes left for Q&A.
Yeah. Yeah, I don't think we can cram in another example, so
yeah,
let's just take some questions. If there are any. Yes.
Here we go.
When you use a supplier, if you call it get twice, does it run the full method twice, or does it save the result and it provides it?
Okay, so the question was in the example with the supplier, when we call get and actually execute it, does it execute twice or multiple times, or does it store the result? Well, the answer would be it will execute twice. Otherwise, the JDK or JVM would have built up a huge cache of return values and so on. And of course, there's nothing preventing you from writing a Lambda with side effects, so you have to start thinking about that too.
Question?
You were talking about converting code to Java 8. What's your view on that? When should one and when should one not do conversion without adding functional?
So the question was, when should you or when should you not convert your old Java 6, 7 style of code into Java 8 style of code? Well, first of all, one major benefit of Java 8 is, of course, designing away those subtle bugs that can appear because of your bloatiness, right? But at the same time, you are paying for a risk that you can, like we have shown in several examples, that you're so focused in creating your one-liners that you actually make mistakes. So I would say whenever it makes it simpler and more clear and easier to handle, that's when you should do it.
And I think the same reasoning applies to not just converting Java 8, but converting your code anytime. Like in real life, if you can motivate the cost and time of just rewriting everything, but you don't have to change anything, usually that's not the case. So I guess in practice it would be, oh, I need to change this piece of code because I need to add some functionality or fix a bug. Then that would probably be, if you want to, be a good place to, or time to actually start using Java 8 instead. So, but rewriting it for, I mean, it might be fun, but if you can't motivate that time spent, then yeah, don't just rewrite it.
And I also think that one shouldn't forget that a for loop is pretty powerful.
It's pretty efficient.
It is. So.
Then you have all the readability aspects. You can do things with like streams that would become very nasty for loops. So you have all this. I mean, it's one tool in the toolbox. So it's still not the. We still haven't found the silver bullet, I guess. But it's a good question because it's very easy when you start using it that you find, oh, I found this shiny new hammer. And now I'm just going to go around and whack everything with it because you want to learn it, right? But we all learn by our mistakes. We made that mistake. Thank you.
Thanks. In the example with reduce, I didn't understand how it would work when you have only one item.
Okay.
Okay.
The question was that in the example where we had the reduce, how can it work when we only have one item? So let's go back to that example. We can actually show it real quickly.
If I can remember which one it was.
I think it's like 2, no, 4, I don't know. Not that one. No, 7. There we go. Fantastic.
Okay, so what happens if, you repeat the question. What happens is reduce method will only be called if there actually is more than one element. That's why it works, because as soon as you call this, it's going to blow up. Right, so if the stream is empty or if there's just one element, there's nothing to reduce. So you're never going to call this.
You're saying that reduce will not be called if you have only one element?
Yes. So reduce will not be called if you only have one element. Or none-element.
Otherwise, if we just passed in 5, in this case, it doesn't have a duplicate, we would still blow up if the reduce method would be called. But it doesn't. So
that's actually a pretty neat trick.
So and in this case, since I mean, obviously, if you have a stream that you will always have multiple items, you wouldn't. This example doesn't have that. But then there's actually difference between reduce versus like find any. Reduce actually goes through all the elements. But in this scenario, reduce is only going to be called when there is a bug. So
I guess we're sort of out of time, but maybe a quick one. I saw a hand raising up there. Okay, so the question was that what's the problem or challenges with having a team where you have experienced Java 8 people and those that are less experienced, like they're in Java 6 or 7. And I guess our experience is that you get to do a lot of cleanup. There are being constructs that are not done the proper way, and you also have to explain a lot. So Java 8 is really a game changer. Those that are not working with the language and not reading up on it are going to get behind. That's unfortunate, but I think that's reality.
And I think another important point is in your team. I mean, obviously you can't have a team where some members write codes that the other team members can't understand. So you kind of find, I guess you have to ease into it and find a level that is suitable for your team. And eventually, I mean, when you see new stuff, it's hard to read. It doesn't mean it's complicated or anything. It's just you don't understand it. But you will gradually increase your knowledge about this type of syntax and just bring the team up as a whole.
All right, I think time's up. So thank you so much.
Thank you.